find the length of the line segment that starts at the point -4, -8, and ends at the point 8, 6. So let's begin by recalling that the length of a line segment from, say, a point x sub 1, y sub 1 to a point x sub 2, y sub 2 is defined using an adaptation of Pythagorean theorem. So we say that this length L is equal to the square root of the change in the x values squared plus the change in the y values squared. So our first point, point A, we'll label this as x sub 1, y sub 1, has the coordinates -4, -8, and our end point, x sub 2, y sub 2, has the coordinates 8, 6. So we want to take these ordered pairs and plug them into our distance formula. So we can say that the length of the line segment, or the distance between these endpoints, is defined as this big ol' square root of 8 minus a -4 squared plus, we have 6 minus a -8 squared. So looking within that radical, we can see, hey, we got a negative times a negative and another negative times a negative. So we can rewrite this as the square root. So we have 8 plus 4 squared, so that's going to give us 12 squared, plus 6 plus 8 gives us 14 squared. And it can be tempting at this point when we have a square root and we see those perfect squares, we want to cancel. But remember, we can only cancel by factoring. So incorporate parentheses if you tend to make that mistake. And this is going to be equal to the square root of 12 squared is 144 plus 14 squared is 196. So we have 144 plus 196, which leaves us with the square root of 340. So we want to see if we can simplify this a little bit further. So looking at this integer, 340, we want to look for perfect squares within the factors. So I think the easiest factors to see right off the bat are 34 and 10. Well, neither of these are a perfect square, but that's okay. They're both even. We know that 34 is equal to 17 multiplied by 2, and we know that 10 is equal to 2 times 5. Hey, we've got 2 appearing twice here. So we can say that this is equal to the square root of 2 squared multiplied by 5 multiplied by 17. So we can, now that we have this factored, we can separate this out into the square root of 2 squared multiplied by the square root of 5 times 17 gives us 85. So now we are officially ready to simplify. The square root and the square will cancel each other out, leaving us with 2 times the square root of 85. So we can say, therefore, the length of this line segment from point A to point B is 2 times the square root of 85 units long. So this is the length of our line segment and our beautiful final answer.